So now we're looking at this negative 45. Since it's negative, it must mean we're multiplying a positive number by a negative number. The only way you can get a negative answer when you multiply is when you have different signs. Now we look at the number 45. We're looking for two numbers that multiply to 45, but since this is minus, they have to subtract to 4. Now, the only thing that I can think of that multiplies to 45 is 9 times 5. Of course, 45 and 1, but that obviously doesn't work. And obviously, this is the right combination because when I subtract 9 and 5, I do get 4. But now I have to be careful. Since these are different signs, I have to be careful where I put the number. The middle sign is negative, means I have to put the larger number, which is the 9, by the negative, which means the plus goes with the 5. It wouldn't have made a difference if I had put the m minus 9 first and the m plus 5 second. But it would have been wrong if I had put the minus with the 5 and the plus with the 9. That was question number 17. Now question number 18 looks like this. It's 3a squared minus 21a plus 30. And again, my first step is to look for a common factor. And in this case, there is a common factor because this 3, 21, and 30 each have a factor. Each could be divided by 3. So the first thing I do is take out the 3. I put the 3 in the front, and this will give me a squared. 21 divided by 3 is negative 7, and 30 divided by 3 is 10. So inside my parentheses, I get a squared minus 7a plus 10. Now this itself is a trinomial, so I'm going to try and factor that trinomial. And here it's an a squared, so I'll break it up into a and a. Again, I look at my signs. My last sign is positive. That means both signs have to be the same. They both have to be the minus. And we're now looking for two numbers that multiply to 10. And when we add them, they give us 7, and that's obviously 2 and 5. And I could have put the 5 first and the 2 second. They're both minuses, so it wouldn't make a difference. Don't forget to make sure to keep that 3 in the front. So this has a common factor of 3 and binomial a minus 2 times a minus 5. So that was through number 18. I'm now going on to question number 20, unless somebody has a question before I go on. Okay, I see some people are working with us. Great. Thanks for those chats. Okay, so now I'm looking at number 20. And number 20 says factor 4x squared minus 49. It's not a trinomial, it's just a binomial. Again, our first step is to look for a common factor, but there isn't any. So when it's binomials, I then look to see if I have what's called the difference of squares. Is 4x squared a perfect square? Yes, it is. It's 2x times 2x. 49 is also a perfect square. That's 7 times 7. And there's a minus before it. You have to have all three of these things. If you do, then you can break this up into two binomials, 2x and 2x in both parentheses, 7 and 7 in both parentheses at the end, with one being a plus and one being a minus. You get 2x plus 7 times 2x minus 7. In other words, you get conjugate binomials because, and remember, when we multiply conjugate binomials, we get a binomial, not a trinomial, because the inner and the outer cancel out. So that's why we're able to factor the difference of squares. Now the next one I gave you was 921, which was 9x squared minus 121y squared. Again, I look if there's a common factor, but I don't think, but 9 does not go into, or 3 go into 121. There is, again, no common factor. Again, it's a binomial that happens to be the difference of squares. 9x squared is 3x and 3x. 121y squared is 11y and 11y. Again, in one we put a plus and one we put a minus because it's difference of squares. Again, it wouldn't have made a difference if you put the one with a minus first and the one with a positive second. And 22 is w squared minus z squared, which is again the difference of squares. So again, there's no common factor, but we can divide it into w and w for the first, z and z for the last, and again a plus in one and a minus in the other. So that were questions 20 through 22. Any questions on these? Okay, so then I will go on to question number 23. Now in question number 23, it says factor completely 4x to the third minus 8x squared minus 12x. And again, as in all factoring, I look for a common factor first. And there is a common factor. 4, 8, and 12 all have a common factor of 4. Also, each of the terms happens to have an x in it. And the lowest exponent I have is the plain x, the x to the 1. So my common factor is 4x. When I put 4x into 4x cubed, when I divide it, I get plain x squared because the 4's cancel out and the 3 minus 1 exponent gives me 2. Then 4 into negative 8 is negative 2, and x into x squared is x. And finally, 4 into negative 12 is negative 3, and the x's cancel out so that I'm left with a trinomial x squared minus 2x minus 3, and I'm going to try and factor that. And I always say I'm trying to factor because it's not always possible to factor. Not everything is factorable. Not everything can be put back to simpler forms. Most of the time, if they give you the question, it's going to factor, but it is not necessarily factorable. So now we break up this. Again, we have x squared, so we're going to break it up into x and x. We jump to the last term, which is negative, means one is positive and one is negative. And we're looking for numbers that multiply to 3. Since this is a minus, they have to subtract to 2. Obviously, those numbers are 1 and 3. And since the middle term is negative, the larger number, the 3, is going to go with them negative, and the 1 is going to go with a plus. And don't forget that 4x from the outside. So your final answer is 4x times x plus 1 times x minus 3. Okay, we're up to 26. 26 says 4s to the fourth minus 12s to the third minus 8s squared. Okay, again, we look for a common factor. I'm sorry, left out the s here. And 4 goes into all of them, so 4 is a common factor. And if I look at the variables, they all have s's, and the smallest exponent is 2. So 4s squared is my common factor. Okay, let's see what happens when I divide out the 4s squared. So the 4 into 4 cancels out. S squared into S fourth gives me S squared. Remember, we're subtracting exponents. 4 into negative 12 is negative 3. S squared into S third gives me S to the 1, which is just a plain S. And finally, 4 into negative 8 is negative 2. And S squared into S squared cancel out. And again, I'm left with a trinomial in the parentheses that I'm going to try to factor. So the S squared I break into S and S. Again, I look at my last term, it's negative. That means one is plus and one is minus. And we're looking for two numbers that multiply to 2, but when I subtract them, give me 3. Hey, wait a second. There's no such thing. No numbers can multiply to 2. The only two numbers that multiply to 2 are 1 and 2. And when you subtract them, you're going to get 1. You're not going to get 3. In other words, here is a case where it's not possible to go any further. This is our final answer. This trinomial is what we call prime. A prime trinomial, or a prime number, is a number that can't be broken down further. This would be my final answer. Okay, so now we're looking at question number 27, which says factor completely 9x squared minus 81. And again, like I keep repeating, look for a common factor first. There happens to be a common factor of 9. This will give me 9 times x squared, and 81 divided by 9 is 9 itself. I know this looks like the difference of squares, but first we have to factor out the common factor. Now, if you notice, what's left, the binomial that's left in the parentheses is the difference of perfect squares. So I can go further with this. I can break the x squared minus 9 into x plus 3 and x minus 3 with a 9 on the outside. If you didn't take out that common factor of 9, you did not completely factor this, and that would be considered wrong. If you got this on a midterm and you were asked to completely factor, it's not completely factored unless you've also taken out the common factor. Are there any questions on any of these? Okay, so then I will be going on. We have 2 more left to do. We have number 28, which is 12x to the third y minus 75xy to the third. And again, what we want to do is see if we have a common factor. Now, if I look at 12 and 75, there is a number that goes into both 12 and 75. That's the number 3. So put that on the outside. Then I look at the x's. There's an x to the third and an x. So since they both have x's and the lower exponent is just the plain x, x is my common factor. Then I go back to the y's. There's a y and a y cubed. Again, they both have y's. The lower exponent is the one with the plain y. So 3xy is my common factor. I always look for that common factor first. Okay, now let's see what we left in the inside of the parentheses. So 3 into 12 is 4. X into x third. Remember, you're subtracting exponents. 3 minus 1 is 2. So this is x squared. And y into y just cancels out. Okay, now we get to the next term. 3 into negative 75 is negative 25. X into x cancels out. y into y third is y squared. And lo and behold, what is left inside the parentheses is the difference of squares. This is a perfect square, this is a perfect square, there's a minus in between them. Mind you, if this would have been a plus, I would have had to stop right here. Has to be the difference of perfect squares, which this is. So I can now break this up into my two conjugate binomials, 2x and 2x as the first, 5y and 5y as the second, and then one a plus and one a minus. Again, the one with the minus could go first and the one with the plus second. It doesn't make a difference. So that takes care of the homework that I had given you from the practice sheet 4. And I would like to now go on to the next topic, which is, again, we're finishing up factoring of trinomials. But before I do that, I'd like to tell you what your next test is going to be like. I hope to finish up most of chapter 4 today. If we don't finish it completely, we certainly will by Tuesday. So I would say there are two things. I'm going to give you a test on Delta Math, which is going to be really like a pre-test. I'll call it a pre-test. If you get in other words, if you do well on that, I'll count it as a test. If you don't do too well on it, I won't count it. I'll just count it as a homework. So it'll only go into your average if I think it's worth it. In addition, sometime in the following week, I am going to give you a test on all 4 chapters on Blackboard. I think I will do it, probably I will schedule it after the following Tuesday. In other words, coming Tuesday's date is, a week from today is going to be the 8th. So coming Tuesday is the 6th. The following Tuesday is the 14th. No, the 13th. On the week of the 15th, I will be giving you a test on Blackboard. I'm going to write this all down on Blackboard and in your email. I'm going to give you a Blackboard test, multiple choice test, similar to what the midterm is going to be like. It's going to be practice for the midterm. It's also going to be considered a test. So, but I'm going to do it after we have next week, after I've assigned the test on Delta Math. Now, this message that I'm giving now is for those people who somehow have not finished up their Delta Math assignments. I have extended the due date to all these assignments. So there is a little bit of a penalty for not doing it on time, but make sure you get all those assignments done. Now, for anybody who took test 1 and feels they now know how to do it better and would like a better mark, let me know, because I can reset the mark. I can reset it to 0 and you can start from scratch. But you can only do that if I have evidence that you have gone to tutoring. If you've gotten tutoring on that, then I will allow you to retake that test. That's because it's the first test and it's still people having problems with the technicalities of everything. If you want, you have to let me know, either in person by talking to me before class or after class on Zoom, or by emailing me. Let me know, because I have to be able to reset it, and I won't reset everybody's mark. Most people who did very well. I was really pleased with the marks. If you're still having problems, please get in touch with me so we can see how to satisfy your problem. Does anybody have any questions? Any questions at all? Okay.
So you're saying that so I have missed one of the homework assignment.
Go back,
So if
you'll see that it's open again.
Okay, all right, thank you.
I think I left them open until October 30th. I mean, I gave a really long space. It's more important to look at, I really want you to do well in this course. I don't want you to do lousy. So if you've had a problem for not being, but you have to know the work. So let's work together. I'm willing to give you extra time. Just let me know what you need. I have to hear from you because it's very hard to be here so remote. It really is remote. It's remote for you, it's remote for me. Let's try and make it as good an experience as possible. Everybody okay with this? Okay, so going on then, I want to talk about the next type of factoring. Which is also a type of trinomial factoring. However, I want to get some examples here. However, the leading coefficient is going to be something other than 1. What do I mean? Let's say I had something like this. 2x squared plus 7x minus 15. If anybody's interested, I'm using the textbook and it's section 4.4. So if you want to know what type of problems I'm looking at. Here we have a trinomial, and what we have here is a trinomial that starts with a 2, doesn't start with plane x squared, and the 2 does not factor out. There is no common factor. So we're now talking, some people call it what's called the AC method. There's a number, the first number, the number in front of the x squared is called the A. The number in front of the x is called the B. And the number that stands alone without any x or any variable is called the C. So this method is sometimes called the AC method, because what we're going to do is we're going to take this trinomial and somehow break it up, the middle term, into 2 pieces. So instead of having just 3 terms, we're going to add 4 terms. Because remember, the first type of factoring we actually did was something that was called grouping, where we had 4 terms. So that's what we're going to do with this. And in order to do that, what I do is I multiply the A, the leading coefficient, the number in front of the x squared, times the C, the last number, the number that has no x in it at all. So 2 times negative 10, negative 15 gives me negative 30. And here's what I do. Again, I look at the sign, just like I did before when we were doing the trinomial factoring. We look at the sign of the last number. It's negative, so one number is going to be positive and one number is going to be negative. And we look for 2 numbers that when they multiply, they give me 30. But when I subtract them, because this is a minus, they give me 7. In other words, I ignore the 15. Instead of the 15, I use the negative 30. Now, what numbers multiply to 30? Well, 5 and 6, 10 and 3, 30 and 1. I think that's pretty much all the choices. Do any of these subtract to 7? Yes, obviously 10 and 3. And since this is a positive 7, it's going to be a positive 10 that we're going to have. and a negative 3. In other words, I'm going to take this 7x and rewrite it as positive 10x and minus 3x. Notice positive 10x and negative 3x is positive 7x. Now I bring the whole thing down. I bring down the 2x squared, and I also bring down the 15, the negative 15. So I have changed this trinomial to a polynomial with 4 terms, and now I'm going to use grouping to factor it. Group it, factoring the 2x squared and the 10x has a common factor of 2x. When I factor out the 2x, I get x plus 5 is as my binomial in the parenthesis. Now I go to the second group. It's negative 3x minus 15. There is a common factor, and since the leading coefficient of this group is the minus 3x, I include the negative 3 as part of the common factor. So negative 3 into negative 3x leaves me the x. The negative 3's cancel out. And negative 15 divided by negative 3 gives me plus 5. And I see that my common binomial factor is x plus 5. So I put the x plus 5 in one parenthesis. And in my second parentheses, I take whatever is on the outside of those parentheses, which is a 2x and the minus 3. And this is how it's, oh, yes, much more work than just plain trinomial factoring. But this allows us to factor trinomials even if they don't start out with an x squared. They start out with a leading coefficient other than 1. Does anybody have any questions before we try another one? I'm going to do another one completely, and then I'm going to give you one to try on your own. Any questions? Okay. I have to erase this because it just takes so much room. Okay, here's the next question. Two x squared minus 13x plus 15. Okay, I'm going to put a line here so I can do the AC business over here. Okay, again, no common factor. So I have to multiply the A, the 2, by the C, the 15. That will give me positive 30. Again, first thing and last thing. Now I look at the signs. The sign here is positive, and two numbers multiply to a positive number if they both have the same sign. They're either both positive or both negative. Since the middle term is negative, they're both going to be negative. It could be a negative and a negative. Okay. And now we look at the numbers that multiply to 30. And there are a bunch of them. 5 and 6, 3 and 10, 2 and 15, 1 and 30. I think that's it. I think that's the combination. So now, since this is positive, we need them to add to 13. Well, of all of these, the ones that add to 13 are the 3 and the 10. So I am going to rewrite this negative 13x as, remember, they're both going to be negative, negative 3x and negative 10x. Now, it doesn't matter if you put the 3 first and the 10 second or vice versa. You will come out with the exact same answer. You just rewrite the rest of it. This stays 2x squared, and this stays plus 15. Notice if you combine it, if you had combined the negative 3x and the negative 10x, that's the negative 13x. But we wanted to separate it so we would have 4 terms. Okay, in our first group, I have a common factor, just a plain x. So this becomes x times 2x minus 3. In my second group, first of all, I'm starting with a negative. So part of my common factor is negative, and 5 goes into both of them. So my common factor is negative 5. And negative 5 into negative 10 is 2. X just comes, gets brought down. And negative 5 into positive 15 is negative 3. And again, we have a common factor, binomial factor of 2x minus 3. And what goes inside my second parentheses is what's on the outside, x and minus 5. Again, if you would do FOIL on these two binomials, you would come right back to this. Are you ready to have an example to try on your own? Okay. Thank you, Nikisha. That's beautiful. Okay, so I'm going to give you, let's say, 2 problems to work on while I take attendance. I haven't taken attendance yet. So let me give you 2 problems. First one is 6a squared plus 7a plus 2. And the second one is okay, this is a little bit harder. 3x squared minus 19xy. I'm sorry, plus 19xy minus 14y squared. Okay. And I'm going to take attendance now while you're doing this. I'm going to stop the video. Somebody remind me to start the video again. Resume recording. Okay. We see our leading coefficient. The number in front of the a squared is a 6, and there's no common factor here. So we know we're going to have to do the AC method. So we're going to take the 6 and multiply it by the 2. And we're going to get plus 12. And looking at the signs, because I always take care of the signs, this sign is positive, means both signs are going to be the same. The middle sign being positive means both signs are going to be positive. So we're looking for numbers that multiply to 12. Remember, we ignore the 2. We look at the 12. They have to multiply to 2, but when we add them, they have to add up to 7. And I think everybody would see that it has to be a plus 4 and a plus 3. In other words, I'm going to break up the 7a into plus 4a and plus 3a. And bring everything else down. So here's my 6a squared, and here's my 2. Notice I do not use the 12 anymore. The 12 is just to help me break this up. Now here's what we're going to break it up into. Here's our 2 groups. the first group, 6a squared plus 4a, has a common factor of 2a. So if I take the 2a on the outside, I will get 2 into 6 is 3, and a into a squared is a. And 2a into 4a, well, the 2 into the 4 gives me 2, and the a's cancel out. In my second group, 3a plus 2, there is no common factor. The only common factor there happens to be 1. And since the middle term, this starting term, is positive, it's going to be a plus 1. Usually we don't put 1 as a common factor on the outside, but when we're doing this grouping, this AC method, we have to have some number outside the parentheses. If there's no common factor, that number has to be a 1. And what stays on the inside is a 3a plus 2. And now we see that our common binomial factor is 3a plus 2. And the second factor goes into the second binomial is the 2a and the plus 1. And I did see that there were several people that did get this answer on the chat. Very good. Looking at this next one, the 3x squared plus 19xy minus 14y squared. If you recall, I told you it looks very confusing when you have two variables. So for the moment, pretend that there's only one variable. There's only the first variable, the x squared, and leave out the y's. In other words, change this or rewrite this as 3x squared plus 19x, forget about the y, minus 14. And factor this trinomial. It's not an easy factoring, but it doesn't look as confusing as the first one. Trying to factor this, I look at my numbers. First, there's no common factor, so I have to multiply the 3 times the negative 14, which gives me negative 42. The a times the c is negative 42. Now, first of all, the fact that it's negative means one number is going to be positive and one number is going to be negative. And we want to see what numbers actually multiply to 42. Well, there's 1 and 42. There's 2 and 21. There's 3 and 14. There's 6 and 7. I think that pretty much takes care of all the possibilities. There might be others, but this is what I can think of. But since this sign is negative, we want the two numbers to multiply to 42, but subtract to 19. Well, that must be the 2 and the 21. And since this is a positive 19, it's going to have to be the 21, that's the positive, and the 2, that's the negative, because the larger number has to be positive. So I rewrite this now as the 19 as minus 2x and plus 21x. Remember, negative 2x plus 21x is 19x. And just bring down the first term, the 3x squared, and the last term, the negative 14. So now I have 4 terms, and I can use grouping. Okay, grouping in the first group, 3x squared minus 2x. The only common factor happens to be the x. I put the x on the outside, and I get 3x minus 2 in my first parentheses. Then I go to my second one. First of all, 21 and 14, obviously there's a common factor of 7. And since the 21, the leading coefficient of this group is positive, it's going to be a positive 7. So positive 7 into 21x gives me 3x. 7 into negative 14 is negative 2. You always know you're on the right track when you look at the two binomials that they got and they look the same. So your common binomial factor is 3x minus 2. And the other factor in the second parentheses is the x. This is not a line, this is just a line. X and plus 7. So that's how this would have factored. 3x squared plus 19x minus 14 factors to 3x minus 2 and x plus 7. But that's not what I really wanted to factor. I wanted to factor 3x squared plus 19xy minus 14y squared. And if you recall, what I just tell you to do is just write these things except put a y at the end of each parentheses. In other words, put a y next to the 2 in the first parentheses and a y next to the 7 in the second parentheses. And this will be the answer to your original problem, 3x minus 2y and x plus 7y. And that's probably one of the hardest kind of factoring you could be asked to do. Okay, let's just try, let's say, one more. What if I gave you this example? (40r to the third minus 120r squared plus 90r. I'm going to give you a few minutes to try this. Don't forget that the first thing you have to look for whenever you're factoring is there a common factor? I'm going to put this on pause for a minute again. So we factored out the common factor of 10r, but we were left with a trinomial of 4r squared minus 12r plus 9. And this is all a trinomial that doesn't start with a 1, has a leading coefficient of 4. So I'm going to try and factor this 4r squared minus 12r plus 9 further. Okay, let's do that over here on the side. In order to do that, I have to multiply the a, the 4, times the 9. That gives me a positive 36. Now that means, first of all, I always deal with the sign first. Since it's positive, the two numbers are positive, the two numbers multiply to a positive answer, they must be the same sign. Since the middle sign is negative, they both must be minuses. Okay, so now we're looking for numbers that multiply to 36, but when we add them, they're going to give me 12. Well, I think everybody might see that it's 6 and 6. In other words, this 4r squared, I'm going to rewrite the negative 12r as negative 6r and negative 6r. I'm breaking up the negative 12r into two negative 6r's. I leave the 4r squared, I leave the plus 9. So now I have my 4 terms, so I can do grouping. In the first group, I have 4r squared minus 6r is 2r as a common factor, and 2 into 4r squared is 2r, and 2r into negative 6, the 2 into negative 6 is negative 3, and the r's cancel out. Okay, then I take my second group, which is negative 6r plus 9. And there is a common factor. 6 and 9 have a common factor of 3, but since the leading coefficient here is negative, it's a negative 3 is my common factor. And negative 3 into negative 6r is positive 2r. And negative 3 into positive 9 is negative 3, because a positive divided by a negative is negative. So my common binomial factor is 2r minus 3. And the other factor, what I get from outside that, is also 2r minus 3. In other words, both parentheses, both binomials are 2r minus 3, which I could write more succinctly, quickly, by writing it as 2 minus 3 parentheses squared. It's a binomial squared. Don't forget there was a 10r on the outside. So this would be your correct answer. It would not be wrong to write it as 10r times 2r minus 3 and 2r minus 3. But probably on a multiple choice question, this would be the choice rather than this. Are we pretty much set with this? Any questions about this? If not, I'm going to go on to the next topic, which is the last topic in this chapter. It's something called quadratic equations. Okay, I'm erasing this. We started out the term solving what were called linear equations. That was the first topic we touched, and those were equations that we solved where the highest exponent in our example was a 1. It's called linear or first degree. The highest exponent you're going to see on those are 1. We're now going to something called quadratic equations. And in that case, our exponent, we're going to see an exponent of 2. For example, 2x squared equals 5x plus 3 is an equation that is called a quadratic equation because what we see is a exponent of 2. And we solve quadratic equations in a totally different way than we solve linear equations. We know with linear equations we get everything, all the x's to one side, all the numbers to the other side, and then we divide by the coefficient. How do we solve a quadratic equation? Well, I'm going to put this one on the side because it's a little bit harder. And I'm going to start with an equation that's a little bit easier. And then from there, we'll come back to this one. So let's say I gave you this equation, x squared minus 6x minus 2x minus 24 equals 0. We see it's a quadratic equation. Now people sometimes tell me, oh, I see it's a quadratic equation because it equals 0. No, it's a quadratic equation because what we have is an exponent of 2. So we know it's a quadratic equation just like this. This didn't equal 0, but it was a quadratic equation because we had an x squared in it. We have something with, it's a second degree equation. It has an exponent of 2. What we do with a quadratic equation is, if I see it's a quadratic equation, I make sure that I get everything all the numbers, all the letters, everything to one side, equaling 0 on the other side. So we want to put our quadratic equation in what we call standard format, which is where we have an x squared term, then an x, then a number equaling 0. And what we do with this is usually we're left with a trinomial that we factor. Okay, we're going to learn the method of factoring today. There is another method that we can use. It's called the quadratic formula that we're going to learn a little bit later in the term. But right now we're doing what's called the factoring method to solve quadratic equations. Okay, we, like in all factoring, look first for a common factor, and there isn't one. So we open up two parentheses. I know I don't need to do the AC method because my leading coefficient here is 1. It's just a plain x squared. So I can break this up into x and x. Remember our rules. The last term is negative, means one is positive and one is negative. In order to have a product that's negative, you have to multiply a positive number and a negative number. So we're looking for two numbers that are going to multiply to 24, but when we subtract them, they're going to give me 2. And I think those numbers are going to be the 4 and the 6. And since the middle term is negative, the larger number is going to be the negative 1, and the smaller number is going to be the positive 1. In other words, I'm going to be a +4 and a -6. So this is no different so far than what we did until now, the last couple of lessons. When it comes to a quadratic equation, they're going to say solve the quadratic equation, and you're going to know it's a quadratic equation because it's going to have an equal sign. It's going to be an equation. That means it's going to be equal to something. So when you're solving an equation, you don't want to just factor, you want to figure out what x is. Now, I'm going to give you the thinking, and then we'll just talk about the method. What do I have here? I have, let's call this x plus 4. I don't know what x is, but x plus 4 is some number. Let's call it a. And x minus 6 is a different number. Let's call it b. Since I don't know what they are yet, which numbers they are, so I'm just going to call them a and b. What do I know about a and b? A times b is giving me a product of 0. They're multiplying and their answer is 0. Now 0 has a very interesting individualized characteristic, and that's the fact that if two numbers multiply to 0, it must be one of them has to be equal to the 0. Either the a equals 0 or the b equals 0. It doesn't matter which one, but you can't get a 0 as an answer when you multiply if you're not multiplying by a 0. Either the first parentheses, the x plus 4, has to be equal to 0. That's my a. Or the second parenthesis, x minus 6, which is the b, has to equal to 0. It turns out there are going to be two legitimate answers to this equation. If x plus 4 equals 0, I can figure out what x is by bringing the 4 to the other side. So one answer is going to be x equals -4. And the other answer is when x minus 6 equals 0, that's when we add 6 to both sides, and we get our second answer, which is x equals 6. There are two answers to this equation, -4 and +6. So after we've factored, we then go back to the we separate each factor separately and put each factor, each parentheses equal to 0. And that gives us a very simple equation to solve, and that gives us our answer. So that's what's called solving a quadratic equation. Let's try now this equation, the one I gave you first. Okay. Any question before I erase what I have here? Okay. This was the one I wrote first, and I said I knew it was a quadratic equation because I saw an x square in it. So if I see an x square in that equation, I know I have to solve it the way I solved this one. In other words, what I want to do is get it equal to 0 and then factor. When I want to get it equal to 0, I look at the x squared term. I always want my x squared term to be positive. This is positive, the 2x squared. I don't want to change it. If I would bring the 2x squared to the other side, it would make it a negative. So I'm going to want to leave the 2x squared on the left side. Again, I determine that because that's where it's positive. Which means if I want to get this thing equal to 0, I have to get the 5x to the other side and the 3. So I'm going to subtract 5x from both sides. And I'm going to subtract 3 from both sides, which will give me 2x squared minus 5x minus 3 equal to 0. I want to make sure that when I have my trinomial all on one side, it's in standard form with the x squared term first, the x, and then the number, which this is. Okay, after I do that, I then want to factor. Well, first I look for a common factor, but there is no common factor. So then I use my AC method. I multiply the 2 times the negative 3, which gives me negative 6. Negative means one is going to be positive and one is going to be negative. And we need the numbers to multiply to negative 6 and subtract to 5. If two numbers that multiply to 6, but when you subtract them, give me 5, has to be 6 and 1. Notice, don't make the mistake of saying it's 2 and 3. 2 and 3 add to 5, but we need numbers not that add to 5. This is a minus, so they have to subtract to 5. It has to be 6 and 1. And since the middle term is negative, the larger number, the 6 is going to be the negative, and the 1 is going to be the positive. So I'm going to rewrite this as 2x squared plus 1x, which is just plus x, minus 6x, minus 3. Now, there's nothing wrong with putting a 1 there, but it's not necessary. If you want to do it, fine. Taking out the common factor in the first group, it's just an x. So it becomes x times 2x plus 1. In my second group, 6 and 3, my common factor is 3. But since it starts with a minus, negative 3 is the common factor. Negative 3 into negative 6x is positive 2x. Negative 3 into negative 3 is plus 1. And I see that my common binomial factor is 2x plus 1. That's the first factor. And the second factor is whatever on the outside, which is x minus 3. I have now taken this expression, this 2x squared minus 5x minus 3, and factored it. And now, since it equals 0, I'm going to set each of these factors separately equal to 0. I'm going to give you 2x plus 1 equals 0 as one for one answer. And your other answer is going to come out to be x minus 3 equals 0. And I have to finish this. I don't stop right here. I want to get what x is individually. So 2x plus 1 means subtract 1 from both sides. I'll get 2x equals -1. And then there's a number in front of the 2. I have to divide by it to get the x alone. So my first answer comes out to be -1/2. That's one answer. What about my other answer? Well, I have x minus 3 equals 0. I also have to get the x alone, so I'm going to add 3 to both sides. And this gives me x equals 3. So here are my two answers. Remember, it's a quadratic equation. I expect to get two answers. One answer is -1/2, and one answer is 3. Does anybody have any questions about this? If not, I'm going to give you one to try. Okay. A little bit different looking. Let's see if you could do this. 100x squared equals 300x. If you notice, I put on the board homework. There is obviously going to be delta homework, but also from sheet 4, I want you to finish the rest of sheet 4, which is questions 19, 24, and 25, and questions 30 through 38. We will be going through those on Tuesday. Remember, there's going to be a Delta Math test next Thursday. I'm going to put it on, post it on Thursday. I'll give you a couple of days to get it done. And there's going to be the following week a test on Blackboard on chapters 1 through 4. So Delta Math test is going to be from chapters 3 and 4, which is what was after the first test. Again, if anybody wants to redo that first test, I've extended the due dates. If you want me to reset your test, you have to let me know, and I will let you know what I want you to do in order to do it. Okay. See if we can do this problem. Okay, let's finish this up. I want to solve this equation, and the first thing I notice, it has an x squared. It means it's a quadratic equation. And when I have a quadratic equation, I want to set it equal to 0, which means since this side has the x squared and it's positive, I'm going to bring the 300x to the other side. I'm going to subtract 300x from both sides. Which will give me 100x squared minus 300x equal to 0. It's not a trinomial, it's just a binomial, but again, the method is factoring. And the first type of factoring we always look for is a common factor. And between 100 and 300, 100 is the common factor. And also x squared and x is a common factor. So my common factor is 100x. And when I divide the 100x squared by the 100x, it leaves me x. And negative 300x divided by 100x is negative 3. So in factored form, this becomes 100x and x minus 3. I do have two factors, even though this one is not in parentheses, it is a factor. One is 100x and one is x minus 3. Now, when you have a common factor, if it doesn't have any x next to it, let's say it's just 100 as your common factor, you can't set it equal to 0 because 100 can only be 100. But if you have 100x, if you have an x there, it is a factor that can be set equal to 0. So one factor is 100x will equal 0, and the other is x minus 3 equal to 0. I get two factors and I set them each equal to 0. In order to solve this, I have to divide both sides by 100. And 0 divided by 100, 0 divided by anything is 0. So one answer to this question is 0, x equals 0. So sometimes you do get an answer that is equal to 0. It's perfectly fine. The other answer I'm going to do by setting x minus 3 equal to 0, I'll bring the 3 to both sides, the other side, and that'll give me x equals 3. So my two answers to this problem are 0 and 3. Again, I won't say 100% of the time quadratic equations have two answers. Sometimes the two answers turn out to be the same answer, so that's why we'll say it's only one answer. But usually you have two individual answers. You want to look for two answers in a quadratic equation. Okay, let's see what my question is. Good, Hoda. Okay, I'm going to, I think it's clear as to what you should be doing as of now. You're supposed to be finishing up sheet 4, which is questions 19, 24, 25, and 30 through 38, plus going on to Delta Math. Again, if you have not completed any of the assignments on Delta Math, look at them. The due date has been extended so that you can complete them. It is very important that you get this done. Okay, I'm going to let everybody go. I have just wanted to speak separately with Faria. Well, everybody have a good day.
Bye.